Great. So, so Amy invited me because I do wearable technology, but actually, I also do a lot of other stuff, which is Internet of Things related. And so, actually, when I heard about this afternoon, I actually thought that the research that we have done for this product called Hackable, that I've been working on for the last 3 years, is actually much better documented and also much more interesting from a research perspective. So I do think there's a lot of overlap between the problems that you encounter in IoT and in wearable technology. So I thought actually talking about this is a really interesting way into also looking how that fits in. So designing for the Internet of Things. Let me tell you a little bit more about the company that I work for. They're called Made by Many, and they're a digital agency, which is the easy way of saying it, but they call themselves Innovation Accelerators, I think, which basically means that we work with companies to provide digital products and services, and we may do that through either engaging with our customers, or it can be completely internal inside the company and making their own processes better so that they can provide better services. So for example, if that sounds a bit abstract, we work with ITV to make sure that they got a better content management system, which made sure that they were able to break news faster than any news website in the UK. So these are sort of business targets, but they're facilitated through digital innovation. And in general, we just get quite an open brief, and then we start sort of not trying to, build something very specific, but, we look at the business targets, we try to reach those, and we engage a lot with users in order to understand what it is that is the best product that we make. So what we trust a lot on is process, and I think you also see that through what I'm going to show you today. So just to give you a more bigger question, how can you create intuitive designs for screenless and buttonless devices that empower users? So I think this is exactly where there's a lot of overlap between IoT and wearable technology, which is, I think you're seeing the shift where a lot of the computing is shifted off the device that you can see. So a lot of it is in the cloud, or it might be on a phone that you're carrying with you, which means that the device or the piece that you're wearing either becomes a point of display, or it's where you're collecting your data. It becomes, if in order to make it beautiful, very often you need to make it quite abstract. So how do you make a product that people feel that they understand and they can engage with, and they they can really sort of feel confident using, regardless of the fact that it doesn't give you the obvious screen that you would normally get. So I'm going to try and answer that through this product Hackable that we made, and actually we're very fingers crossed, because something can always go wrong, but we're probably hopefully shipping this week or beginning of next week. So this is so exciting, because we've been building this product. We launched our Kickstarter in February last year, so it's been a while, and we're very excited. So Hackable is the ball you can program. So it's got sensors, it makes sounds, it vibrates, and it's got an accelerometer and a gyro. So it can it can measure how you're using it. So we call it the computer that you can throw, which I think tells you enough about sort of the troubles that you go through when you're trying to build a product like this. Just to kind of give you, I'm going to show you a minute of video to explain the product a bit more. Do we have sound for that?
Like any ball, kids can throw, catch, kick and bounce hackable. But unlike other balls, hackable is packed with sensors, lights, sounds and vibrations, all protected by a tough, kid-proof rubber shell. Using a free app, kids can program hackable with a powerful set of rules that have been designed to introduce them to the principles of coding. Hackable teaches kids to make, test and learn as they explore and experiment with technology. Shake it, throw it, spin it, or bounce it.
It's a really long video, so I'm just stopping it right there. But this is the essence of it. We had an accelerometer and gyroscope, and you can kind of imagine that you can do things with that. But then you need to sort of translate that back to language that people understand when they're using a ball, and also things that you can actually deliver. So the ones that we ended up with were still, hit, shake, roll, throw, drop, spin, and count. So these are things that were sort of engaging enough, and from doing multiple user testing, these were things that people understood well, but also things that we could, for example, the count, you can easily start making stuff like times tables. So there's a nice overlap between learning opportunities and then also play. And then the outputs are light effects, sound effects, rumbles, a clock, counts, and like. So again, this is sort of using all the things that you're able to do as a from just the fact that you're computing, but then mixing that with the ways that you would normally use a ball. An example of how we would use that is we've got this if this then that setup structure. So it's trying to teach kids coding in the very most basic way. So we didn't aim to teach them, for example, JavaScript, because chances that kids are leaving school once they get out into the real world, maybe none of the languages that are relevant now are going to be relevant then. So you really want to teach them the thinking that comes with coding rather than very specific ways of doing it. So if the ball is hit, then light up like a rainbow and make a fart sound and rumble like an earthquake. So it's a very sort of modular way of setting up coding in ways that we try to do it quite openly, so that but then at the same time use evocative names like earthquake for a rumble, so that when kids create games, they can really sort of use it as a way of storytelling as well as making very linear games. So just to come back to why we wanted to do this, so this is a quote by Steve Jobs: "Everyone in this country should learn how to program a computer. It teaches you how to think," which is, why coding is now part of the standard curriculum. We need children to have the tools to access and to choose from a range of different activities. We need them to be active. So I think this is quite a concern among parents in general, that kids are becoming less active and they're more and more engaged with screens. So it's kind of trying to, bring back some of the things that we like about, when we remember our own youth. But then kind of do it in a very realistic way where we know that, iPads are just like such a source of joy for kids these days. And do it very creatively. So Sir Ken Robinson said, "My contention is that creativity is now as important in education as literacy, and we should treat it with the same status." So just to give you a Venn diagram, which explains everything always, that's kind of where we're placing Hackable. Not just STEM, but also STEAM. Really try to teach kids, design and the sort of creative storytelling aspect, together with being active and physical and playful, placing it in a real environment, and then also just teaching them programming logic, but not in a way of like, you have to learn coding because it's going to be so useful for your future, but much more in a way that, it's something that you want to learn because you want to create these games. So it's kind of, for some kids we see that, they love coding stuff anyway, and they will be drawn to it to start with. But we're also trying to sort of get the kids in that would normally only want to play ball outside, and now they get to create different kind of ball games. So they're going to learn this because they want to do the ball games. And then we have got other people who are just much more about storytelling, and they use it as a storytelling device. So it's really trying to engage like a very broad group of kids in all these different ways, sort of to tailor to their interests. We're just getting sort of close to, how do we make sure that Hackable was empowering and intuitive? So in terms of process, the thing that we really stand by at Made by Many is this thing of make, test, learn, which is we're believers very much in the sort of lean methodology and agile ways of making things. So it's really about trying to in every step of the process to very quickly make things, to put them in real environments, and then to also be very clear about when you're testing, what kind of things you're trying to learn from making the specific thing. So in general, this meant that we just put it in the hands of lots and lots of kids. And just to the make, test, learn thing, this is how we build things. And actually, it's also very much how kids create games, it turns out, because they invent games. And so in this case, they would have to program them first. They play them and then they improve on them. So very often you see kids going like, okay, we're going to do this game, it works like this. Then you play it and they're like, okay, it would be even more fun if we put in this thing. So, now we do it twice as fast. So this kind of way of sort of iterating on games actually works really, really well with just, our ideas about how you build technology. So it's like one of these sort of magical ways that things that you already think sort of come together. And that's what Hackable became. So Hackable was co-designed and iteratively developed with hundreds of children and parents and educators. This was, you don't get hundreds of kids immediately, although I guess you could do workshops with hundreds of kids, but that's not how we did it. We really sort of tested with friendship pairs over time and small groups of school children. So usually we would get like 6 to 8 of them together and go to a park and play and just see how they would engage with the product, and also just how they make things more fun and what they think is fun. And what they think is fun is really quite different from what I thought they would think is fun to start with. So I would say, how do you make this empowering and intuitive? Like my first answer to this is, make kids, parents and teachers active participants in the design process. I can show you some examples of how we did this. I'm just going to show you the progression of how we went through different prototypes, and then I've got some documentation of tests that goes with that. So this was our initial proof of concept. And I can tell you this is really hard to test with, and I think there's an overlap also with wearable technology in this, is that you kind of have to get to quite a high fidelity in order to get really good test results. This might not always be true for every product, but if you really want to test something that sort of lasts enough time, you get into similar problems like, connectors failing and stuff just not being in quite the right shape in order for people to engage with it in a natural way. So we very quickly went on from something like this to something more high fidelity. But I think it's important. I'm assuming everybody here knows this, but to not just focus on the technology and to also see like if there's ways that you can model technology. So I think this video also shows us some stuff of how we worked with paper prototypes. So this is a mega big phone, in case you're wondering what that is.
Here's the explosion. Explosion. And then when slap, it could know this what ran back and forth. Everyone then when the ball is in the red zone, and when it blinks blue, that means it's okay to go in. But when it blinks yellow, then it blows red. When it blows red, in the red. So anyone who's in the red zone still, when it goes off, is out. Sound fanfare before explosion. Sound alarm. There's a sound alarm somewhere. No, why don't we just do explosion? What are we going to call it? We can call it time bomb. Time bomb. Yeah, let's call it that. Let me write it so that you
Yeah, yeah. So you can really see that the kids sort of do this game creation quite collaboratively. It's not. I think sometimes people have the impression that when something happens on a computer that it might be quite solitary. But I think in general, like even when kids play alone on iPads, they will very often play together. So they will both be playing the same game, and they're like looking at each other doing it. If you've ever seen kids doing Minecraft, that is also exactly how they do it. So I think it's important to not underestimate how social these activities are. Obviously this was a great way for us to test the app side without physically having to build it. But it's much harder to say like, okay, and now the ball goes red, because it's just not as exciting as it actually going red. So that's why we moved on to a higher fidelity product. We thought this was the MVP at the time, the minimal viable product, but I think it was more like a pre-MVP because it wasn't a real product yet. So this is what it looked like. It looked pretty good, but it really, it wasn't. There was no design for manufacturing happening yet. Like this wasn't something you could give to a factory and say like, okay, build this for me, because it was just never gonna last long. So this one was 3D printed. We also eventually made a version that was cast, but it was already playing with ideas of how can you open it up and then close it back again. I'm gonna have to go through this a bit quicker. Sorry, I didn't see the first one. Yeah. Cool. So basically, I'm gonna skip over that. Yeah, so I think one of the great things that once we had a higher fidelity product, even though it was still breaking quite regularly, we could test much better with kids. So this is an example of how we were testing. We had built a prototype app as well. So these are all games that kids have made. I especially love all the emojis in there. So they were really, I think a lot of the games, they really surprised us. They were really quite sort of what we would call random, but they make total sense to these kids. So they kind of they go into like very crazy different things all the time, and like I would be like, oh, but that makes no sense, and they're like, no, but it's fun. So they've got like completely different objectives because I was thinking that kids were going to make these games that kind of work like the games that you were taught when you were young, but actually they're much more sort of about sort of surprising each other and making each other laugh and just like doing crazy stuff like having to run or having to jump, and it's much more sort of like a vehicle for them to get rid of their energy. So I think this was like big learning for us in order to actually understand what product it was that we were making. So we took this to Kickstarter and made the actual MVP and made it so that it could be designed. So we worked together with MAP, who are a product design agency here in London. So this is where we went really wide again in all the material samples and different designs, and then we ended up making this board, which was the one that we took to Kickstarter, and this is what it looked like then. we tested a lot of the app design also with kids through just trying out all different kinds of ideas and having them tell us whether they understood it or what it meant, because one of the goals for us was not just the physical product to be very easily understood, but also for the app to be very easily understood, because we wanted it to be also for kids who are dyslexic or kids who haven't learned to read yet, or for people just in different countries. So to kind of really open it up and make it much more about understanding the sequencing of things rather than making it about, how well can you read. I'm going to skip through the video, unfortunately, because I don't think we have the time. So after mass production, this is where we are now. This is the final product that we're shipping. Very long story, of course, there, but that's a different presentation. Some nice publications. So just to kind of the second part of answering my question, besides really listening to users and having them tell you what your product is rather than you thinking that you know what your product is, I think it's also very, very important that you build on existing digital design patterns and use behavior that people already use with technology. So I think originally when people were creating these digital metaphors, they were actually looking at how physical things were built, and then they were sort of trying to translate that to a digital world. And now we're in sort of the opposite place where it doesn't quite work the same way, because we're trying to do digital things, but we're trying to do them on physical products. So actually we're translating them back. And in our case with Hackable, we've got 8 lights, we've got some sounds, and we really didn't want it to be a very language-focused thing. So we were trying to use all these sort of light animations in order to make people understand what the product was doing. So we're building on things like, Apple's breathing indicator that showed you that the product was alive. But yeah, I think all these sort of metaphors are, the things that people really easily understand and already sort of are familiar with. So trying to leverage that. And I think another thing is that lights, I would say light is emotion. It really sort of suggests internal states. When the light is going very fast, it tells you that, either something needs to happen very quickly, or, it's like a battery running out, for example, something that requires immediate attention, or, it's something that's very exciting, or something is happening. So you see that people sort of anthropomorphize what products are doing. For example, we've got like a traffic light, which is also something that's very standard in light animations that we're using to sort of show that games are starting. And these are very, very simple things. And I think it's very easy to kind of forget that people need sort of easy pointers, because if you have a product that doesn't have very clear buttons that you can do things with, doesn't have a screen that's explaining stuff, doesn't have language, you really have to kind of use things that people already have in memory rather than trying to be too clever. And you can of course be bold as Apple and try to teach people how to swipe, but I think there's you kind of have to understand where you are in the market, and if you don't if you're not sort of also leveraging this massive network effect of like all these people at the same time learning this thing, then I think if you want people to like your product and to sort of feel comfortable with it and confident in it, I think it's very important to use things that already feel very natural. Another thing that we did was we used shake to play, which is also becoming quite I think an accepted metaphor in IoT products, because it's very satisfying when you've got a product that's not working. You want to throw your computer out of the window when it's not working, right? So like shaking a thing is actually it's the most natural thing to do to make something do something. So we kind of made sure that sort of in different stages, shake was the thing that you did in order to make something happen. So it kind of just makes it very sort of natural and easy for people to engage with. I'm going to skip through this video as well. So just as a recap, how do you create these intuitive designs for screenless and buttonless devices that empower users? co-designing, listening a lot to what people are doing, asking the right questions, and that is very important. It's not just a question of like hanging out with people, but really trying to know what you're trying to learn, but then also at the same time being open to just seeing what's happening rather than the script that you've said. And building on existing patterns. So yeah, I think, don't try to be too clever, try to be easy. I think that's a really, really big challenge for IoT products and wearable technology. Thanks.